Hello everyone, welcome to my channel. My name is Ravi Singh and I'm going to help you understand great engineering concepts around us. For that, you just need to hit the subscribe button down below. Hello everyone, this video is made for discussing some random concepts in thermodynamics. So let us begin. The first concept is quasi-static or quasi-equilibrium process, as we all know, is an idealized process and not a true representation of an actual process. So the question arises that why are we studying it? The first reason is because they are easy to analyze. And why they are easy to analyze? Because we can speak of process paths only in case of quasi-static process, and hence we can represent it like this is the initial state and this is the final state of a system undergoing a process from 1 to 2, and we can represent this process path only in case of quasi-static process, and that's how we are going to analyze it. Like, we can either find the work done or anything that we need by representing this system undergoing the process, just because this is a quasi-static process. Second reason is work producing devices delivers maximum work when they operate on quasi-static processes, and that's how they serve as standards to which actual processes can be compared. The second concept is during a steady flow processes, fluid properties change with position but not with time. Like, suppose I'm having a control volume like this. Mass is coming in from here, mass is going out from here, and this is at time say t1, and the same system at another time, just say after 1 hour, at time t2. So if I'm denoting the temperature, say at point 1, 2, 3, 4, 5, if the temperature here is 50 degrees Celsius, then it can be different at this point, say 45 degrees Celsius, say 55 degrees Celsius, say 65 degrees Celsius and 75 degrees Celsius. So these are the temperatures at different points at time is equal to t1 of this control volume. And here the same system, when represented at a different time, must have the same temperature at this point 1, point 2, point 3, point 4, point 5, meaning thereby that the temperatures can change with respect to position. The temperatures are different, but as the time changes, the temperatures must be same, that it must not change with respect to time. That is the meaning of the steady flow processes. The third concept is that, as we all know, if we want to fix the state of this system, say this is a system, then we need properties. But the question arises, how many properties are needed to fix the state of the system? Because there are an infinite number of properties. This question is answered by the state postulate, which states that state of a simple compressible system is completely specified by two independent intensive properties. So the question arises, what are these simple compressible systems? So first let us see this. Any system in the absence of effects due to external force fields, like example electrical or magnetic, motion, gravitational and surface tension, are said to be simple compressible systems. But what if these are not negligible? Obviously these are negligible in most of the engineering applications that we are going to analyze further in thermodynamics. But what if these are not negligible? If these are not negligible, then additionally we need to consider one property for each of these effects if these are not negligible. And now, since we know that what is simple compressible system, so this state of this simple compressible system is completely specified by two independent intensive properties. Two properties which are always independent are generally pressure and specific volume. So it's better to take these properties because these are always independent and they are obviously intensive in order to fix the state of a simple compressible system. But we cannot take pressure and temperature, because in case of phase change processes, suppose here two phases are existing and here pressure is a function of temperature, that both are dependent on each other, so they are not independent. That's why it is always better, it is always preferred to take pressure and specific volume as those two intensive independent properties. So this is all about this video. Thank you. Also, for more exciting contents about science related stuffs in the form of news, videos or articles, don't forget to like our page Science Talk on Facebook, for which the link is given below.